Today we're going to learn about percent composition calculations. Before the advent of modern spectroscopic methods like chromatography, nuclear magnetic resonance, and gas chromatography, if you wanted to identify something unknown, the best way to do it was to burn it. And that's what chemists would do. They would burn substances in the presence of an abundant amount of oxygen to ensure that it was a complete combustion reaction. And then they would collect the degradation products. And when you're burning something that is pure carbon and hydrogen, the only thing that it's going to generate is carbon dioxide and water. So there are reagents that will selectively capture both carbon dioxide and water. So the degradation products of a combustion reaction can be analyzed and weighed. So if you know the initial mass of your sample, you can find out what percentage of composition the original unknown sample was in terms of carbon and hydrogen. We're going to explore that a little later. Right now what we're going to learn is about percent composition, how to calculate the percent composition of a simple substance. So in example 1, the question is, what is the percent composition of carbon in acetylene? Acetylene has the formula C2H2. The first step is to calculate the molar mass of acetylene, which most of us know how to do. You take the chemical formula and you multiply by the number of elements that constitute it. So acetylene has 2 carbon atoms and 2 hydrogen atoms. So a mole of acetylene would have a mass of 2 times 12.011 to represent the mass of carbon, and 2 times 1.00794 to represent the mass of hydrogen. So the molar mass of acetylene is 26.03788 grams per mole. Now, within a 1 mole sample of acetylene, you would find 2 moles of carbon atoms. So to find the percent composition of a 1 mole sample of acetylene, you would multiply 2 times 12, which is the molar mass of carbon, and then divide it by the mass of the total sample. And then multiply by 100, which I forgot to write in here. The result would be 92.257895%. Given the highest accuracy of the figures in here is 5 significant figures, we can only report our answer to 5 significant figures. So the percent composition, the percent carbon composition of acetylene is 92.258% by mass. In the second example, I asked the question, what is the percent by mass of water in copper sulfate pentahydrate, a molecule in which the crystalline structure includes 5 water molecules for every formula equivalent of copper sulfate. So the formula of copper sulfate pentahydrate is written like this. So it's cupric sulfate, so it's a +2 charge on the copper, sulfate is -2. Then you write a dot and 5H2O, which means the crystal comprises 5 water molecules for every copper sulfate. If you want to find the percent by mass of water in the copper sulfate pentahydrate, then you would find the mass of the water included over the mass of the whole substance. So the mass of water is 5 times, the fact that there's 5 water molecules, and 2 times 1.00794 to include the hydrogen, 15.394 to account for oxygen. So the molar mass of water is 18.01, and we add that on the bottom because the copper sulfate pentahydrate has 5 water molecules included in it. This is the molar mass of copper sulfate alone. The total mass then of copper sulfate pentahydrate is 249.685, of which 90 grams is only water. 90 divided to 49 gives you 36%. I reported the answer to 5 significant figures because the least accurate number in our calculation was the mass of sulfur. So copper sulfate pentahydrate is 36.076% water by mass.